Cool. So we're going to keep learning about the core Python language features, and definitely just keep asking questions as you all have been as we go. And I was just catching up in the chat. Yeah, logsec, Megan, logsec is a great note-taking tool. There's a whole like logsec is a clone of this thing called Roam Research that's amazing, but it costs like $15 a month. But there's a whole what is it called, like Zettel Kasten. It's like a whole thing about like daily note taking and organizing thoughts sort of for academics, and it's kind of become trendy, and tools like logsec and Obsidian and Roam are all about it. But we are continuing with Python. Again, I recommend notes. Definitely for data structures, you're going to want to have a piece of paper to draw stuff out on, really for the entirety of the course. So much of my CS coursework was drawing. We actually would write little programs by hand, which was its own thing. I am going to add the code that I have. I'm going to commit it. And push it up, since that's what I was saying. It's like a good habit of I don't want to accidentally lose this stuff. And we did dictionaries. We pretty much took care of functions. I think we've printed our berries, we've described our berries, we've talked about our berries. In fact, I should probably move and rename the dictionaries file to be dictionaries and functions, because it has both. So, fun fact about Git, it has its own version of move and RM for move and remove, because this way Git can track that we're just moving a file. If I just use the normal move command, Git would be like, one file was deleted, a new file appeared. It's not gonna know that we moved the file. So this lets Git be a little more efficient in tracking stuff. And as I said, I literally just push after every commit unless there's a reason not to. So now we've got if statements and loops. Really, I'll just call this conditional logic, which is a fancy word for if statements and loops. I'll close that out. Do I have my Python REPL running? I do. I'm going to rename the terminal to REPL so I know which is which. I'm going to use that enter program that I like, find star.py, enter conditional logic and loops. And is the font size good for everyone here? I can bump this up if need be.
Can you again go over what that command you ran is?
Oh, the command line enter command.
Yes.
Yeah, I can. It's a little out of scope. Again, so there's this analogy like Linux is like the programmer's workbench, and the idea being then you have all these tools and this sort of philosophy of like one tool for each job. And so people write all these little scripts, all these little command line tools, and enter is one of them. And there's a bunch of ways to install it. They have it on the website how to do it. And what it does is, so there's a bunch of ways to like tell different programs to watch files. So we can tell this program to watch some files that we care about, and when that file changes, do something. Built into the shell is a command called find, which you can use for all sorts of things to find files and directories. We don't talk a lot about regular expressions, but that's how I can find all files ending in py. The star means everything in the current directory. So I want to, and the command line also has this idea of a pipe, because we want to be able to chain these commands together. So I want to find all my files that have .py at the end of them. I want to take that list and send that list, and Linux does this all in text. It's called a stream, to this program called enter. And this program enter, then what it does is it watches those files, and if one of them changes, which happens when I save a file, enter will run a command. And I am telling enter, when any of those files changes, I only care about this conditional logic one, but just for simplicity, I'm sort of doing it this way. When that file changes, run my Python program, right? Run this Python program, run Python for this file. So now I save my file, enter says, hey, it changed. I better run Python. I better run the file itself.
Cool, thank you.
Absolutely. It's a little out of scope, but it is cool to see. And there is a lot of mindset here. And these concepts of streams and piping and chaining do come up. Like, you should think of this as functions passing data through each other like a series of tubes, which we will see more and more as we get into the course. For the moment, though, we are looking at if statements in Python. And we've got a function with a named argument. Not with named arguments, just with two arguments. So the order here matters. And in fact, I don't think I've showed this, but in Python, you can use this special keyword pass for a function when you don't want it to do anything. And I say, I've got my can drink beer function. And so we're going to talk about this in the TDD lecture a bit more, actually, and Francisco may have talked about it a bit yesterday as well. But doing it this way is actually kind of nice, because I make sure that I don't have any typos. Like 10 minutes ago when I had my function name wrong, I can see what kind of data to pass in. I can just do little things to test that, say I'm passing in what I expect, and I can kind of build my function out this way. And so let's add some if statements and some stuff in here to make this code real. So I'm kind of following from the example here, but to talk through it, in the United States, if you're at least 21 years old, or in Canada, I guess, if you're 18, you can drink. So there's a lot of different ways to write this if statement. But this is certainly not a bad way. It is concise and clear and to the point. And I have a squiggly here. Invalid syntax, unknown. Can anyone tell me what I'm missing in online 5?
The age.
Yeah, I have this comparison operator right here, but I totally forgot to compare it here. I could have put this would have caused another problem, but Python is saying, hey, there's a comparison, but you're not comparing it to anything. This squiggly, I am not doing it in the interests of time, but my sort of like linter program wants me to always have like a comment around each method. And there's like a standard way to comment for Python methods to explain them. And you all will see that later in the class. But that's a squiggly I know that I can ignore. But this is why it's a good habit to pay attention to the squigglies, even if you choose to ignore it, because then you won't miss it when they're really telling you something that matters. So now if I'm older than 21, or I'm older than 18 and I live in Canada, I can drink beer. In Python, the else if statement is shortened to ELIF, which you'll see in other languages too. So this is else if the country is Antarctica. I guess nobody can drink. Oh, no. I'm so sorry. That should be true. We all can drink in Antarctica. And then finally, otherwise, we cannot drink beer. And normally you would just put these all like this because they're all pretty short. And it looks like I have, oh, trailing white space. So this is how you write if and else statements in Python. And we have, it's kind of nice because we don't need to use, JavaScript had this and this, and these all have like a lineage, and I think it comes from like how mathematicians like write logic, like Boolean logic, and like so you'll see this come up in Python for certain things. But it is really nice that we can just plain old use or and not. So I want to check in and see if folks have any questions here. How are people feeling? Cool. And just to show you guys,
question.
Yes, what's up?
JavaScript, there were those what was the word, like
Ternary.
terminary? Is that exist in Python as well?
Ternary. Good question. I don't know off the top of my head. I have to look. Let's find out. But he's talking about like can drink equals age greater than 21 through false. Let's if anyone knows, feel free to throw it in the chat. Otherwise, we're gonna really, I guess I need to get in the habit of using ChatGPT, but this is what professional programmers do half the time, by the way. I can't remember anything. By the way, Geeks for Geeks is a pretty good resource. This one looks like it might be a bit better, but let's see. So looks like what you can do is you can put like if else logic on one line and just use if and else. Yeah, I think Python wants you to write it out explicitly. That seems to be the consensus here from a quick Google search, which would make sense with the Python philosophy that we were talking about explicitness and readability, and there being like one right way to do things, which honestly I think is pretty good. Ternaries can be nice for certain things, but there's so much to be said for consistency. Great question. Real quick, I want to refactor this method a bit. We wrote this so that you can see all the if else stuff. But if we look at this, oh, actually, I'm not going to refactor it. I thought there was maybe like a nice simple refactor, but looking at it, I might be underestimating how much time that might take. Any other questions before I dive into looping? Cool. So looping over list elements is pretty straightforward. It looks a lot like a JavaScript for in loop, which I'm so happy that JavaScript has that as a language feature now. If we want to get the, well, actually, first, So this is where Python gets interesting. And this, I will admit, is where I am somewhat rusty with Python because I have a bit less experience using it. But Python gives us a lot of really useful tools that JavaScript is getting better at, but not quite as much. And one of them is what's called a range. And if we print this out, and this is a built-in Python language feature, let's call this 1 to 10, in fact. This is really interesting because I'll just put a cast there. Let me clean this up a bit. So we'll make this 11 just to. This is really interesting. This range function, and this is where VS Code is your friend, returns an object that produces a sequence of integers from start inclusive to stop exclusive by step range. So there's a whole lot of rules. Like we could do a range where it is not just like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's probably a way to do it where it's like 2, 4, 6, 8, and so on, which is just super handy. As you all, I'm sure, have already experienced a lot of the times, you just want to be able to go through some sequence of integers in order. Python, and we'll kind of learn more about classes and see how this is, and this is where some of like having more depth to the Python language than JavaScript is really nice. This is like a range class, right? So it's like its own kind of object. And if I print it, I don't get 1 through 10. But now if I iterate through it, indeed, it generates all those things. So we can loop through it again. And if we just need the range for looping purposes, and of course, what does my squiggly tell me? Non-iterable value range, right? So this is not a useful error message, but what it's really telling me is I needed to pass an argument there. Because range is expecting, it's like a function essentially. So let me check in. I'm curious if folks have questions about ranges. So they're super powerful, and Python sort of builds on all these things. Python also has a concept of what's called like an enumerable, which is sort of in JavaScript, but not so much. Like Python knows what things it can loop through. It can enumerate, which is what that means, go through. And so like if we need to go through a Python list, we don't, and we need an index, we do it a little differently than in JavaScript. And L here is short for elements. And so unlike JavaScript, where that for loop construct requires us to create an index counter, we don't need to do that a lot of the time in Python, which is great. And if we do need an index, we use this class enumerate that basically takes something that we can move through, a list, a range, whatever, and adds an index to it for us, in essence. And if I had to guess, we could probably replace this with my range. And indeed, that works. Um, because Python knows, and we'll see when we learn about classes, we'll see a bit more about how it implements it. But Python can have a sense of like, hey, this is a thing I can loop through. I will create an index, a counter for you. So I want to check in and see what questions people have, because this is pretty cool. And this is stuff definitely that is good to practice in Python. You can also loop through dictionaries. The same way that we did with that for in, which JavaScript did not used to have, but Python has always had. Because Python is in many ways a better design language, though I do love JavaScript. And it does have some very cool design choices. So this is clearly a 5-year-old writing this, right? Because they like donuts but not green beans. Excuse me. And so again, we can loop through here. And if I had to guess, just like that really good question about ordering came up, it looks like Python also pretty much looks at the order in which we declare these keys, these elements in our dictionary. But again, I would not count on that, and I would not use that for ordering purposes, because if I'm a programmer, how can I tell when I'm looking at a dictionary where the order that this stuff is declared mattered versus that it doesn't? And there's a lot of other reasons as well, but that is one of the big ones. So here, actually, I'll change K to key, just so it's a little clearer. We can also, I'm sorry, I just had a brain fart. The Python dictionaries have a great method called values. And in fact, that's what I don't need to do, because I just do that. So that is very useful, depending on what we want to do, right? And this is why people like to talk about Python being elegant in terms of a language design. The last loop to mention is the while loop. I have a little bit of a pet peeve with while loops. Unless you need one, I feel like they should sort of be avoided. They're good for things like if I'm writing a program where the user like types stuff on the command line, I kind of need a while loop so that it's always listening. The reason I say I kind of avoid while loops is because if I screw up the logic in my while loop, it goes on forever. With all these other kinds of looping, even if I screw stuff up, the loop will probably stop. So as a rule of thumb, I would say unless there's a specific reason to use a while loop, or it feels like you have to bend over backwards to avoid it, try to avoid it. Like I would probably use a range or something here, though other people might disagree. This might, I don't know, it depends. And just to illustrate that though, this is the danger. And why I really say, please don't use while-loops unless there's a good reason to. I'll comment that one out. And kill this. And in fact, I must have done that because I see here I'm just getting like infinite nines. I must have gotten something wrong. But right, the loop is going on forever. Not a fan. I just want to pause to see if folks have any questions or anything. Cool. Okay. So I have been talking a lot about sort of Python being like designed a little differently. I'll talk a little bit about what that means. And I'm not sure what to name this file. We'll just we'll see how far we get here with this. Oh, that's why I used to VS Code instead of the touch command. So here's an interesting Python fun fact. The number 5 has some methods. And actually, let's find some. So we're going to learn more about classes next week. So I'm not going to dive into this too much. I'm just looking for something I can use to sort of like illustrate this example. Might be I may come back to this later. I apologize. This may not. Remind me, and I'll come back to this one later. I thought I could kind of show something cool. Actually, I can do it this way. I think that this is what I wanted to illustrate. Let's say I've got a string. I'll put a print statement here so we can see it. And I'll clear this stuff. Everything in Python is an object. Even our primitive data types like strings, booleans, numbers. This is kind of true in JavaScript as well, but Python is much more consistent. So even though I've got a string, I can call a method, a function on that string, because everything in Python is an object. And we're going to learn about what that means more next week when we sort of talk about objects and classes. But hopefully this should be a little surprising and kind of cool. I was trying to remember like one for like a number off the top of my head because I always thought seeing it with numbers is interesting. But right, this would probably throw an error in JavaScript. Um, so even strings, booleans, they're objects. We'll talk more about, again, like sort of what an object is, so like instances of classes. But you all have the essential idea, like an object can have like properties with data and also methods that are like functions that can like interact with that data. So there's a lot of ways to do this, right? And we can do it like this. As well. I'm curious if anyone has any questions. I was about to say, I'm curious if everyone is an object or not, which is not what I meant to say. So you can do really cool stuff with this. Right, exactly. Are we objects? That should be a string. I'll add some stuff in here. So this hopefully should be interesting because all of a sudden I've got this string. I call this replace method on it that says, hey, replace the character G with the string 1, 2, 3, 4, 5. And then that's what's returned into the print statement. And the string young never even makes it out the gate. Right, and then here's another way to do it. Let's replace the Y this time. Oh, we'll replace it with 4, 5, 6 just for fun. And it is, Brian, I know you were kidding. I suppose we are all objects. But I think that is kind of one of the cool things with programming, that you kind of get to decide, like, how do we define like the terms of our universe? Like we don't just play with the Legos. Ultimately, we get to design the Lego blocks and how they connect together. And that's the really cool part. And Dakota, thank you so much for throwing that in the chat. And I'll just sort of repeat it because I think you said it really well. When you create a string in Python, you're actually creating an instance of the string class. And that string class object has methods on it. And methods are basically functions that interact with the data there, such as capitalize. And this goes for all these other data types as well. Yeah, Josh, short answer is JavaScript is not quite the same. And this is where terminology gets confusing. JavaScript has objects, they kind of work differently. Like in JavaScript, I don't even know I don't even know if there's short answer is JavaScript works differently. I guess everything is an object. And Dakota, if you know, please throw it in. Okay.
I've heard it done as in JavaScript, strings and numbers, and I think Booleans are all primitives, but they're assigned a object wrapper, which gives them the methods.
Yeah, and it gets a little weirder because objects in JavaScript have something called like a prototype, and they work differently under the hood.
So it's almost like in JavaScript, you're passing in the primitive type, and then it's kind of all these methods are around it. Rather than in Python, you're creating an actual string object with all these methods.
Yeah, I would not.
So confusing.
It is, yeah. And the object wrapper is part of JavaScript. I would not worry about they're doing stuff let's put it this way. It does not make sense in JavaScript to think of a string as an object or an integer as an object or a Boolean as an object. In some sense, there may be truth there, but it functions differently from how we talk about everything in Python being an object, or everything in Ruby being an object, or everything in, I think, PHP and Java being, well, I'm not sure about Java, maybe probably not Java. Like a primitive, the term primitive means something like, the idea is like, if in my programming language, an Boolean is a primitive data type, it's just true. It's not made up of anything else. It's like if the universe is made up, well, if we pretend that atoms are not made out of electrons and all that other stuff, if the universe is made up of atoms, then the atom is the smallest unit you can get to. In theory, when someone says something is a primitive data type, that means that's the simplest that you can get. Like, you can't break, I think you can't like break down, if a string's a primitive, you can't break it down into something else. And JavaScript doesn't quite work that way, but it kind of makes sense to think of it that way. It really functions differently than other languages, in some meaningful ways. And honestly, a lot of the work with JavaScript has been trying to like paper over the ways that it's been different, though some of those are really cool, to try and make it feel like other languages and be more sensible.
So does Python not have primitives technically?
I think everything is an object. I think that is how it works with Python. Like, literally everything is an object. I would have to dig a bit more. Maybe it has integers, floats, booleans, and strings. Yeah, I think I don't, sometimes the terms get confusing, and I hope I didn't misspeak in talking about primitives. But I am pretty sure, because yeah, everything is an object. Like that, let's actually just do a quick Google search here to make sure that I don't have this wrong, and we'll find a good resource. And then we'll get back to the lecture, because I've digressed pretty far. Yeah, everything is an object in Python. It's turtles all the way down. I'm like 90% sure on this, because string, object, Boolean, object. And in fact, we can see it here, like in the Python REPL. If I just do, like, what is it, type true, that Boolean true is an object of class Boolean. Object of class string. Object of class integer. I suppose we could do type. Object of class type. So, and that's kind of, I think, the big difference with JavaScript. Yeah, the main thing to know, I would say, like in Python, everything is an object. JavaScript objects are kind of different from what we talk about with Python. JavaScript objects are sort of glorified fancy dictionaries. We're going to be doing a lot of Python for the next couple weeks, so it'll help because we'll kind of just be focusing on that. And like the object-oriented programming part of our class is almost entirely Python, because when people talk about object-oriented programming, they are not talking about JavaScript. There's a lot more to it than that, which is actually kind of really interesting. But I think the core thing is this idea, and we'll see it, that like in Python, everything is an object of different types. And that makes it a very powerful language, and a lot of other languages follow that design pattern. and JavaScript is a sort of a weird hybrid. On that note, I ran way longer than I meant to, and I realize we're getting close to lunch. There's actually like a decent amount of stuff for us to dig into more here, but again, I really don't want to rush through things. I think what probably makes sense is, let me take a quick look at what we have left lined up for us. Really quickly, I just want to show, again, another good language feature of Python. And then I think what we'll do is we'll break for lunch and we will just pick it up like probably an hour or an hour and a half from now. We don't there's a bit more to cover with this part, but I will probably power through some parts to make sure that we can spend a healthy amount of time talking about test-driven development. So here's the last thing that I want to show. A Python dictionary, we can do a nice, Python has a nice search feature to find out if a key is in a dictionary. And let me go back over here. And I may have gotten something wrong here. Oh, that would be because I need .keys. And apparently it doesn't like that for some reason. Consider iterating the dictionary instead of calling .keys. Okay, I appreciate that consideration, but I would like to just do this instead. And so let's see what I've got wrong here. And we'll just comment all that out. And then it probably is time for break. So there's a lot of stuff my program is printing that we can ignore. And I probably just should have used the Python REPL to demonstrate this. But this is just what I wanted to show, that we can have a dictionary and we can, using this in statement in Python, just search through our dictionary to see if something is in it. And we can also do it with the values of a dictionary. And then you're in my for time. And people like it. So this is the power of everything actually being an object in Python. Like when you have this sort of consistent foundation for how everything in the language is built, it makes it just a lot easier to do cool stuff and useful stuff like this. And JavaScript is so much better than it used to be, but it is sort of like this Frankenstein language. Though again, it actually has a lot of really cool stuff. So this is probably a good stopping point because we ran a bit long and I want to give us a good lunch. Does anyone have any questions before we break?
Yeah, just a quick question.
Yes, sir.
so at the end of your dictionary, you have donuts, yummy, comma. Is that acceptable to have a comma at the very end? Is that usual?
It is. It's called a
Okay.
trailing comma. It's fine not to have it. I will say the only the JSON data format does not like trailing commas. Specifically, that's like the one gotcha with this. Means like if I put this here, JSON, we will get a complaint. And indeed, it doesn't like the trailing comma. And if I get rid of that, now it should be happy. So we'll see this format. JSON stands for JavaScript Object Notation, which is used for passing like text and data over the internet to make life more confusing. In JavaScript, it's considered, I think it's still considered, it might not matter as much now. For a long, long time, it was considered best practice to put a trailing comma at the end of stuff. And the reason being, one of the flaws of the JavaScript language is there are a lot of silent errors. So like if I don't have a trailing comma and then I add something new to my list, right? Like we had this and now I'm adding candy and I'm saying it's also yummy. I'm pretty sure this little squiggly is just, I don't know. Oh, well, first of all, let's just, const foods equals that. Like if I do this, this is such an easy mistake to make. And then if I run this JavaScript program, we get this error, this breaking error. And we probably would get this error in the browser, but there's a lot of like historical stuff with JavaScript because you might get this error, but then something on the website just doesn't work. So all these best practices basically just evolved to, and sorry, I need to do something real quick to make sure my laptop doesn't die on me. Speaking of best practices. Let's do it the other way. I thought my cable was plugged in, but it should be now.
But yeah, thank you. That
Yeah,
answers the question. I can see how that'd be useful, especially if, another software engineer was going in and changing the code and then they added something, but they forgot a comma. Well,
Yeah.
this ensures that doesn't happen.
Absolutely. Yeah. So much of the best practice and obsessiveness you see around formatting is because of stuff like this. Because if you write tons of code, we just all make mistakes. And so that's why it's just such a habit for me and I don't think about it. I don't know off the top of my head if it's best practice in Python or not, but it certainly can't hurt. And it's probably a good habit because we'll be doing some JavaScript anyway. I don't think the only thing that will complain is JSON. I don't think the Python language will complain. I don't think the Python formatters will complain. So yeah, great. That's actually a really good question. Any other questions before we break? All right, folks, thank you very much.